An open pipe is just a tube in which you can create sound. In fact, in the tube you can create resonant frequencies. Now, the key thing with an open pipe is you have both ends open, and in order for the sound to propagate, you need to create a standing wave inside the pipe itself. Since both ends are open, in order to hear the sound at both ends, you need to have an antinode at both ends, which means if I create just my fundamental, so my fundamental frequency here, I would have to have an antinode at the left end and an antinode at the right end. And the only way I can do that is to actually have a node in the middle. And then just create that one single standing wave. Now, inside of here, what I'm going to end up having is a half loop on the left side, and I'm going to have a half loop on the right side. So it still adds up to be one full loop. Now, if I knew that the length of the tube, or the pipe, is L, that means that my one loop, which is still half a wavelength, would be equal to L. That means L is equal to half of a wavelength. So the length of the pipe, 2 times the length of the pipe, is equal to the wavelength. This should be lambda here. So 2 times the length of the pipe is equal to the wavelength. Now if I look at the wave equation, so I know velocity equals frequency times wavelength. If I just substitute that in, I know that velocity is equal to the frequency times 2L, which means if I divide both sides to find the frequency is equal to the velocity divided by 2L. Now the reason I'm going to divide that is because I know that the speed of sound is going to be a fixed value. And I can actually create a certain length of a pipe here in order to create a certain frequency. So if I wanted to have, let's say, 1,000 hertz, I can actually create a certain length here to have a fundamental frequency of 1,000 hertz. And then from that, I can actually have my resonant frequencies. In fact, if we look at the next possible that we're going to have, this is our first overtone. So our next possible frequency that we're going to have inside of our pipe, we still need to have an antinode at each end. The only way to actually get that to occur is to create a standing wave where you actually have one full loop in the middle, then you have the 2 half loops on either side. So this ends up being 2 loops. So if this is 2 loops, and the length of our tube is still L, because that's not going to change at all, that means that the 2 loops is equal to 1 full wavelength. That means L is equal to 1 full wavelength. So if I use my wave velocity equation again, so velocity equals frequency times wavelength, I know velocity equals frequency times L. Now, if I divide both sides again, I have velocity divided by L equals the frequency. What's important about that is that if I compare it to this is basically saying that frequency is equal to 2 velocity divided by 2L, or frequency is equal to 2 times velocity divided by 2L. This is the fundamental frequency, velocity divided by 2L, which means this is 2 times that fundamental frequency. So if this were 1,000 hertz, this would be 2,000 hertz. So that means that this next overtone, or this first overtone I should say, the next resonant frequency that we have in here is going to be our second harmonic. So we can actually hear 2 times our fundamental frequency just by creating a slightly additional standing wave in here, so where we have 1 additional loop. Now, if we continue on then with our second overtone, for this to occur, I have to create an additional loop. So in this case, we have 3 loops. And again, if the length of the tube is L, because that's not changing at all, that means that 3 loops is equal to 3 halves, or 1.5 wavelength, which means that L is equal to 3 halves lambda, which means lambda is equal to 2/3 L. That should be an L. So if I use the velocity equation again, so velocity equals frequency times wavelength, plug this in, have velocity equals 2/3 of L, frequency times 2/3 L, which means if I basically multiply both sides, do a little bit of manipulation, I have frequency equals 3V over 2L, which means that's equal to 3 times V over 2L. So you can see that the pattern continues. This was 2 times the fundamental. This is going to be 3 times the fundamental. So this is going to be our 3rd harmonic. And that should keep going forever and ever and ever, where you just have the next multiple of your fundamental frequency for your next resonant frequency. So you can create these tubes for specific frequencies, but also for different harmonics of the frequency just by creating additional standing waves inside your open pipe.